Thanks, Oscar. Good afternoon, everyone. My name's Ken Sang. I'm the founder of AnyTrip. Today, my presentation is on how we built turn-by-turn navigation solution for bus drivers using free and open source software and open data. Firstly, a little bit about us. We're a startup based in Sydney. We build geospatial solutions mostly for transit operators. If you're a bit of a transit nerd like myself and you live in Australia and New Zealand, you might have used one of our apps. One of the cooler features is you can see all the vehicles, public transport vehicles around you in real time. A bit like Flight Radar 24, but for public transport. So just a bit of fun. If you haven't checked it out, have a little look. But on to bus driver navigation. I guess this is really the problem statement. A lot of transport operators around the world suffered a bit of a driver shortage after COVID. They let go a lot of drivers, a lot of them retired, and once everything got back into gear, there was a bit of a knowledge gap with all the new bus drivers. A lot of the new bus drivers coming in, they also expected digital driver aids. So they're used to Google Maps, Apple Maps, Waze, these apps giving them turn-by-turn navigation like you would in your normal car. But the industry is still very much paper-based. If you've sat at the front of a bus before, you might have noticed that they have these slips of paper that are attached by rubber band or by clips. That's the instructions that the drivers get for driving the bus. So, I mean, in theory, they should know it, but if you're new, you might be struggling. They just have small print that says, turn left at this street or drive at 150 meters and then turn right. It's not really usable while you're driving. The consumer navigation apps, like your Apple Maps, your Google Maps, they don't always work. There are bus-only roads, there are turning restrictions, like there are narrow streets that buses can't go down. Buses also don't go, the shortest path from A to B. They go down defined routes. So the use of these consumer apps, they might help in some situations, but they're quite limited. So we worked with some transport agencies to identify some of the requirements and set out to build something that met those requirements. So firstly, operators wanted to be able to install these devices on buses without a SIM card, without internet connection. So it needed to work offline. Drivers needed to be able to select trips, specific trips, not just routes, because a single route might have multiple stopping patterns depending on the time of day and so forth. We also wanted to make sure that the bus companies have a way of defining the specific routes and roads that they go down, and that they have the ability to change that through somewhat existing processes. And I guess the final two is making sure there's an up-to-date road network and it's relatively low cost. So the solution, luckily for us, a lot of the components and data already exist in one form or another. Firstly, transport agencies around the world, they typically publish timetable and route shape data as open data. Your Apple Maps, your Google Maps, apps like ourselves, we use this data to help you get from A to B. So in theory, all you need to do is take this data, match it to a road network like OSRM, chuck it through a routing engine, and Bob's your uncle, right? Well, that's probably a bit of a simplification. We'll talk about some of the challenges that we had. But first, what we ended up building, a cross-platform iOS and Android app. We used React Native, which if you are into app development is a bit of a yikes, maybe, but we'll get into why we did that later. We used MapLibre Native and PM Tiles to render the base map. We used the operators' timetable data that they provided in GTFS format. And we used OSM for the base map and routing data. And then for the routing engine, we ended up choosing Valhalla. And we'll go through each of these in a bit more detail now. So firstly, the timetable data. We don't really get much of a choice here. It's whatever the operator or the transport agency gives you. Typically, this is in the GTFS format that I mentioned earlier. This stands for General Transit Feed Specification, but it was created by Google. The G originally stood for Google. It's basically just a zip file of CSVs. It's linked together much like an ordinary relational database. You get data like stops, trips, routes. Shapes is optional, but that's kind of the file we're interested in. Mentioned earlier that this is open data typically, and but the data quality and the processes of how this file is generated varies quite a bit from jurisdiction to jurisdiction. The shapes.txt file is the one that's a bit more interesting for us. It's basically a big CSV file of points that form line strings. It's used to visually depict the route that a trip goes. The file itself is optional, and the quality of it also varies a fair bit. Typically what happens is these get created when the route first gets established, and then they're not kept up to date after that. They would have been generated with a road network that's probably several years old, and sometimes they might even be manually drawn if the road network data is missing in that area. So, and within these transport agencies, the purpose of the data might not be actually to depict the route that the bus goes down. It might just be to make it look pretty on a map, but it might not be reflective of what the bus would actually do. So it's important for us to work with the data provider to understand how this data originates and how it's maintained, if at all. Usually it's not. Onto the road network data. We had some choices here to make. Obviously, there are some open data sources available, like OSM. There are commercial providers for map data as well. What really decisions we had to make were really around cost and licensing, especially for a solution that needs to work offline. Commercial providers charge you an arm and a leg to give you access to that. The other thing is up-to-date data. OSM, you can download it whenever and wherever. You can get daily snapshots, but you can also get a live updating feed. So that gives us a lot of flexibility. And finally, the flexibility of us being able to update the data ourselves without having to wait for third parties to correct the data. That was a huge swaying factor. For us, the obvious choice was OSM, but some customers would prefer to use their own internal road network, for example. And it is just a data set after all, so we could theoretically switch between different road network data sets. On the software side, we also had some choices to make around routing engines. There are plenty of options available. You can go with a commercial SaaS provider. We just call an API and not have to worry about it. Again, the licensing considerations we were talking about earlier come into play here. If you're using it in an offline situation, there might be restrictions around that. So the requirements for us for a routing engine were you needed to be able to do map matching, so from the shape file that the operator gives you to the road network, be able to pre-compute these navigation instructions, and then for a more future use case scenario, being able to do offline routing as well. So at the end of the day, we went with Valhalla. It provided an output in what is typically an open source standard format, OSRM now, but OSRM is also a routing engine in itself, but the format that Valhalla allows you to select can be OSRM format as well. And it allows us to switch engines in the future if we wanted to as well. And Valhalla, as a towel-based routing engine, we can more easily run on the device as well in the future when that situation arises. Now we needed a way to bundle the tiles to render the base map offline. Historically, we would have bundled a MB tiles file as part of the map app asset. But we love the flexibility and speed of PM tiles. And now that it's supported natively in MapLibra native, the single flat file, the entire tile set being in one file, and the fact that it's like one command to extract a subset of regions and it returns the data back in seconds, not minutes or hours, means we can move much quicker. And another advantage is we can serve the exact same tile set with the exact same file, just from object storage for an online version as well. Finally, for the onboard navigation, when we were building this, some of the free and open source navigation SDKs out there like Ferrostar, they were still very much in their infancy. We also needed to roll out additional capabilities like next stop announcements. So as you approach a stop, it will say you're approaching a stop. So we decided to roll our own solution. And and decided to implement this in React Native because it allowed us to basically implement one source code base, and it works for both Android and iOS. Obviously, there are some minor performance impacts with this, but typically with this type of deployment where the tablets are plugged in, the tablets are relatively modern, this is more than adequate and fine. On to some of the challenges. So one of the first and, most obvious challenges is matching the operator data to the road network. So the shape data that the bus operator gives us might not be up to date or accurate. We alluded to this earlier. New roads get added, but the shapes are just a one-off exercise sometimes. So here's an example of one where the bus shape the operator gave us suggested doing a sharp U-turn, and then going down a one-way road. And so their data is in red, and the match that we tried to do is in blue. Basically, we have to go back to the operator and go, can you have a look at this and see if you can fix it? Because our matching engine isn't able to cope with this. And hopefully they have existing processes that allow them to go back and make these amendments. On the OSM side, new roads get added, but they might not be contributed right away. We occasionally also observe incorrect tagging that happens. Obviously, the good thing is we can contribute and update these and fix it upstream. The other thing we know that happens is bus-only roads and busways aren't as well maintained, just because the use cases for them aren't as common as your standard roads. So it's good that we are using it and then being able to contribute back. The guidelines for busways is also an interesting, the guidelines for tagging busways in OSM is also quite an interesting challenge. So the guidelines basically say you should tag all busways the same way. It's the same tags, including ramps and slip roads. And often the names are also the same. So say it's a southeast busway. It doesn't matter if it forks to two different directions, it's still part of the same busway system, it's the same name. And that makes generating navigation instructions for these quite challenging because it's the same road, effectively, it's called the same thing. There's no off-ramps. The instructions might not be clear to drivers, so we have to work out clever ways to override those taggings to make those navigation instructions more useful or understandable to drivers. U-turns are also an interesting one. So this is where buses do a U-turn mid-route. It's quite common for school runs. But one of the issues that we found is that some matching algorithms, they heavily penalize U-turns to the point where they just give up. And the context here is the purpose of these APIs are typically to match GPS traces to a map network, not to match two different road network, effectively, data sets together. So we came up with novel ways to sort of identify these U-turns, split them up into separate trips, if you will, and then combine them together at the end. This one's another classic one. GNSS doesn't work in tunnels. So we didn't find this to be an issue in some of the initial regions we rolled this out in, but in some jurisdictions, they have a very big underground bus roadway network. And accurate dead reckoning is not really possible with these consumer-grade Android devices. So, and not all tunnels have these leaky feeder or BLE beacons to be able to do sort of indoor navigation. So we're continuing to work on workarounds for this, including just showing instructions until you get like a list of upcoming instructions until you get GPS again. But this is an ongoing field that needs a bit more work in. Some learnings. We rolled this out to over 3,000 devices. We used low-cost mass-market tablets. They're easily replaceable if they fail. We used heavy-duty fixed mounts on the buses. The suction cups were prone to falling off. And each new region we deployed in, we found new gremlins and new learnings, and it's all interesting problems to solve, but a lot of fun. Obviously, one of the other great advantages is with this, we can contribute back to the open source community, open data community. We have a process to automatically flag when the data doesn't match, we have a process then to go in and identify where the error is. Is it in the open data that the operator provides, or is it in the OSM data? And if it's something that's wrong that we can correct, we can go and correct it. If it's not, then we report it upstream and hopefully that gets fixed. And yeah, hopefully everyone in the open data community benefits from it. And with that, that's it from me. Any questions?
Indeed, thanks Ken for the presentation, and like Ken says, does anyone have any questions? You've got plenty of time for them. I can see one there. All right.
Thank you for your presentation, very interesting stuff. I have worked on similar things here in Auckland, and one particular issue that we've had with looking at routing for buses is when there's a diversion. So if there's an accident or something and you have to go off the normal route, and in the past we've had incidents of buses being stuck because they can't go around a sharp bend, or there's too many cars parked on either side of the road, and it's a problem for fire engines as well. But what's your experience been with those types of issues, and is there anything that could be done to improve those?
It's always a fun challenge, that one. So I feel like this one actually depends a lot on the way that the roads themselves are managed. So depending on the jurisdiction you're in, you might have different levels of government that manage different parts of the road. And sometimes there's databases which accurately tag or depict which roads are suitable for buses to use. Typically they're mapped against internal road networks, not OSM. But there are also jurisdictions where it's all one entity, and that makes it a lot easier because they own and manage the entire road network. They have visibility across that whole situation. Ultimately, it comes down to whitelisting and blacklisting roads. The dynamic routing when you go off route, that requires you to obviously dynamically tell you, okay, this is how you get back to the route, but you can't go down these particular roads because they have sharp bends, they're too narrow, and so forth. I don't think it's a solved problem. It's going to be an ongoing challenge, but the devices which have online connectivity, you can always have a control room specify which roads to go down when those diversions happen, and that's probably the most robust way of providing that information.
Do you have any monitoring of the timetable versus the time the bus actually is to see whether it's late?
So for the driver, it visually presents down the bottom corner to say it's running late or early or so forth. We have an online version as well where we report back to basically an operations center. Also have APIs that expose this information out to customers. It really depends on the model, but there are operators out there who don't have expensive vehicle tracking solutions which produce real-time feeds, and for those, they were happy to use our solution to monitor their performance and also provide that information to the public, so you know when buses are running late and so forth.
Thanks for the talk. Do you use Valhalla for the map matching too?
Yes. Yes, with the caveat of when we know that the map matching doesn't work, we might adjust some of the points in advance before sending it over. And for example, the U-turn scenario that I was talking about earlier, that both the entire, at the end of the day, the map matching happens in Valhalla.
Mm-hmm. One last question is what cities are you operating?
I don't know if I can disclose those, but you might be able to work it out from the presentation. But it's in Australia. Yeah.
Thanks.
Oh yeah, thanks for the talk again. So you mentioned you've had 3,000 deployments already. So do you get a lot of feedback from bus drivers about that must be coming in quite thick and fast, right? Yeah.
Hopefully they are pre-vetted in the sense that the operator runs the routes first before handing it over to the bus drivers. So in terms of the matching to the road network, we're hoping that most of those issues are already pre-captured. Obviously, when new roads open and it doesn't match, yes, a bunch of complaints come in and we'll have to handle those. We do get a lot of feedback from drivers about features or font sizes and, you know, whether this can be here or this can be another color. They typically get captured by the agency first and then triaged before they get to us, because for us it's one of those things. It's like you can't please everyone, so they prioritize it, and if they find that this is actually something that everyone agrees on, then maybe they will request that we make amendments and so forth.
Much good feedback?
I mean, overall, I think people are very happy, drivers are very happy, yeah. I think the feedback that we get is they're particularly happy with the next stop announcements, meaning as you approach a stop, it'll go, you're approaching a stop, and that prevents you from missing stops, which is actually a thing that happens a fair bit when it comes to new bus drivers.
Oh, good. Thank you.
Hi, I just wanted to ask about the GTFS data you get. Do you know if there's any tooling that people use to create that, or is this people sort of trying to fill in spreadsheets as best they can? Just to try and understand the quality.
Yeah. Most scheduling softwares are able to output GTFS. So these are, assuming you're a large enough bus company, you would be using one of those commercial vendors that have these software. There are also smaller players, and there are also open source tooling available to generate these GTFS files. But you run into issues where when you generate it, the shapes, they might be automatically generated. So you run into those same issues where you have to actually make sure they reflect what the bus drivers do. But if all else fails, a spreadsheet can also generate these GTFS files with a lot of manual work.
And with that ends the Q&A for Ken's session. So once again, please give a warm round of applause to Ken. Thank you.
Thank you very much.